All right, here we go. Question number 1. So we are finding the limits as x approaches infinity. What was our strategy for doing these? You just did it. Hopefully you have a strategy. Yes, Artie. Yeah, multiply 1 over the highest x value that was in the denominator. So we would multiply top by 1 over x, everything on the bottom by 1 over x, and then see what happens. But there's another method we could use, but I haven't demonstrated it, so I thought I would demonstrate that one with these questions. What I could do instead is I could factor out that highest degree x term. So if I factor it out, I get something that's kind of similar to when I multiply top and bottom by 1 over x. And then in this case, the x's would cancel out, and then I have the 2 over x, which again approaches 0, and I get the result. The limit is equal to 1. Good. And as x approaches negative infinity, the result is exactly the same. Most of the functions that we'll look at will be like this. So we often won't do both the limit as x approaches negative infinity and as it approaches positive infinity. But, well, I'll say we won't often write them both down. We'll write down one of them, and then we'll kind of think through, does the same thing happen with the other one? There are functions where we have a horizontal asymptote only on one side of the graph, or we may have different horizontal asymptotes on the left and the right side. Those functions we don't see very often, so most of the time just doing one side will be good enough. All right, and what this tells me is y equals L is a horizontal asymptote. And that'll be the case if as x approaches negative infinity or positive infinity, my function approaches some constant value. All right. So in this section, what we're doing is we're just looking at asymptotes. And we use limits to confirm asymptotes and to find out what's happening on either side of an asymptote as well. So as we look at number 3, because my function has a non-permissible value where x is 2, if I find the limit as x approaches 2 from the left, well, as x approaches 2, my denominator goes to 0. My numerator just goes to a constant. And whenever the denominator goes to 0, the numerator doesn't. My whole rational function goes to infinity. Right? Yep. So I know that this is infinite. But I do want to think about, is it positive infinity or negative infinity? So the way we thought this through was to say, well, if I'm approaching negative 2, I should say positive 2, my numerator is a positive number. In the denominator, if I'm approaching negative 2 from the left, so here's my number line, there's my negative 2, I'm coming from this side, I'm slightly smaller than negative 2. And if I, positive 2, why do I keep saying negative? I'm not sure. As I approach positive 2 from the left, slightly smaller than 2, minus 2, gives me a negative number. Positive over negative is negative, so I know that on the left side of 2, my graph is going down towards negative infinity as a y value. And similarly for number 4, since my denominator goes to 0, my numerator doesn't, my whole function is infinite. Is it positive or negative? And I think it through, my numerator is positive. My denominator, if I'm approaching 2 from the right, I'm a little bit bigger than 2. A little bit bigger, minus 2, gives me positive. So I'm approaching positive infinity, which gives me information about my vertical asymptote. So if as x approaches some constant from the left or from the right, and I'm getting positive or negative infinity, then that confirms that I have a vertical asymptote for that value of x. All right. So I will have you try this check your understanding question, and I'd like you to find the horizontal and vertical asymptotes if there are any. There you can see my work for finding the horizontal asymptote. So this time, if I do the limit as x approaches infinity, I go through the process, I get to this point on the right-hand side. All of these terms go to 0. And that's true whether I'm approaching positive infinity or negative infinity. So that's why, so I get to this point and then I think, is it true for both infinities? If it's true for both, then I can go back and I'll put in the plus minus. You may not be allowed to do that in a future calculus course, but I'm going to say for us that's good enough. Okay, rather than having to write it all out for x approaching positive infinity and then doing exactly the same thing for x approaching negative infinity. So we'll just be a little more efficient that way. And that gives us our horizontal asymptote of y equals 2. Good. Then for the vertical asymptote, well, first, notice for the horizontal asymptote, it's most useful if my numerator and denominator are in expanded form. For vertical asymptotes, factored form is better. So I factor it, find a common factor. Since it cancels out that x plus 2, I have a non-permissible value. We know we have a point of discontinuity, but it's not a vertical asymptote at x equaling negative 2. Just a side note, if I had two factors of x plus 2 in the denominator, it wouldn't be a point of discontinuity, it would be a vertical asymptote. So if one cancels out but you're still left with one, it'll be a vertical asymptote, I should say. Okay, so I'm going to approach 3 from the left. And again, my denominator goes to 0, my numerator doesn't. But as I'm approaching, my numerator will be a positive number. My denominator will be negative. Positive over negative gives me a negative infinity. So as I'm approaching 3 from the left, I know my graph is going down. So I can kind of picture what's happening. And then as I approach 3 from the right, it's positive infinity. Not always opposite infinities, just our examples so far have been. Good. All right. So this chapter is all about curve sketching. So we're going to use asymptotes and intercepts to sketch a few graphs. As we move through the chapter, we'll add more and more types of information that we add into our curve sketching process. For now, we'll just look at these two. So, intercepts. I know that when x is 0, y will equal 0. So I have an intercept at 0, 0, which actually gives me both x and y intercepts. So I have a point I can plot, 0, 0, a point on my graph. Next, let's look for horizontal asymptotes. So here I'm looking as x approaches infinity. Well, we already did this, right? So this is the same as the function we used in questions 1, 2, 3, and 4. So as I come back here, I had the horizontal asymptote at y equals 1. Okay, so I'm just going to say C, numbers 1 and 2, and I have y equals 1. But I'm going to get a little bit more information. Sometimes we can get this information, sometimes we can't tell. But I'll sketch my horizontal asymptote there. And the information I'm going to explore is at my left and right end, as I approach this asymptote, can I tell if it's coming down from above or coming up from below? Because that will help me be more accurate in the sketch of my graph. So as I look at this expression that I have, so maybe I'll write it on the next page, with 1 over 1 minus 2 over x, okay? So we had this limit as x approached infinity of 1 over 1 minus 2 over x. Maybe I'll look at both of these. Going to negative infinity as well. 1 over 1 minus 2 over x. Okay. So as I'm approaching positive infinity, the 1 will always be a 1. This one, always a 1. But what's happening here? As I approach positive infinity, this whole thing is going to 0. As it goes to 0, since I'm going to positive infinity, I have 2 over a positive number, right? But I'm subtracting 2 over something really close to 0. So if I do 1 minus something really close to 0, my denominator is actually less than 1, right? If the numerator is 1, denominator is less than 1, is my fraction bigger or smaller than 1? So I have 1 on top and something slightly less than 1 on the bottom. It's going to be bigger than 1, which means as I approach to positive infinity, my graph is coming down from above because I'm slightly bigger than 1 as I am approaching infinity on the right side. That's giving me some information about the graph. As I said before, sometimes we're not able to do this. It's just too complex. We'll hit a question like that later today. As x approaches negative infinity, again, this is going to 0. My numerator will be 1, but now I have 1 minus 2 over a negative number. So subtracting a negative, same as adding. So 1 plus a tiny number is slightly greater than 1. 1 over something slightly bigger is actually smaller than 1, right? So this whole thing is less than 1, which means I'm coming up from below as I'm going to negative infinity. So gives us some information about the graph. Vertical asymptotes. Let me just bring up the chat here in case any questions show up. So far we're good. So here we're going to look at questions 3 and 4. And we found that our vertical asymptote was y equals, what was it? 2. So I'll draw my vertical asymptote there. And then I'm going to look back at this information and see, as I approached, whoops, that's not the question. This is the question. As I approached 2 from the left, I was approaching negative infinity. My y value is going down. So that tells me my graph is going down here, which we might have just guessed anyhow. But there is the possibility that my graph could go down here and then do a swoop up like this. So don't want to assume that's not going to happen. So this information helps us out. Luthman. Why, yes, it should be x equals 2. Thank you. I think there was a Bing online for that as well. X equals 2. So we're going to throw that away because that was just a guess because we just figured out that we're going down here. So I know what's happening on the left side. Here down to negative infinity, up through my intercept, and then to the horizontal line there. Thank you, Peter. And then on the right side, what we found was, as x approached 2 from the right, we were approaching positive infinity, so we know our graph is going up there. So we have our graph like that. Not spectacular, because there's probably some symmetry, probably comes a little bit further in here, but given the information we have, I'd say that's a good enough graph. Yes. Yeah, so what we did in Math 30-1 is on either side of the vertical asymptote, we found a test point. Our graph could even be more accurate if we did a whole bunch of xy values, but I don't want you to. What I want you to do is be able to show me you know what the graph looks like, given the information we're getting from limits and then from derivatives as we go on. Grab some R. Oh yeah, that hand over there. Hardev, go ahead.
Sorry, could you explain again how you know that it's going down on the left side of the vertical?
Yeah, maybe I'll rewrite it down here. So as we do a limit as x approaches 2 from the left of x over x minus 2. Since our denominator goes to 0, numerator doesn't, we got the infinity. And so then we said, well, if I'm approaching 2 from the left, then I think, well, there's the number 2. I'm approaching it from here. So I have something smaller than 2. We could say, well, let's just imagine that's 1.9. I don't want you actually to plug in a 1.9. I just want you to think what's happening as we get closer. But for now, just to help us, imagine this x is a 1.9. If I do 1.9 minus 2, this will give me a negative number. And it doesn't matter how close I get to 2, as long as I'm coming from the left, it'll always be a negative number. My numerator, as I approach 2, will be a positive number. So the positive over negative is giving me the negative for that infinity. How's that, Hardev? Welcome. Any other questions? Nope. Let's do another example. So this is not one we did earlier. But again, as I look at intercepts, because I just have an x in the numerator, 0, 0 will be a point on the graph. Excellent. And that's my only x and y intercept. And then as I look at horizontal asymptotes, I will do the limit as x approaches infinity of x over x squared plus 3x minus 10, which will be, when we use that strategy, 1 over x squared multiplied on top and on the bottom. As x approaches infinity, I will get 1 over x on the top, 1 plus 3 over x minus 10 over x squared. Goes to 0, goes to 0, to 0, and I get 0 over 1, which is 0. So y equals 0 is my horizontal asymptote. So did we do this faster in Math 30-1? Why, yes, we did. But this is why we were getting the answers we did in Math 30-1. We just didn't have a notation to show what we were actually doing. So I do expect you to show this work. So let me draw that in. Horizontal asymptote about there. So notice my graph is going to pass through that horizontal asymptote. Notice as x approaches infinity, the horizontal asymptote is just telling me what happens at the extreme right end of the graph. What I didn't talk about is, well, what if it's approaching negative infinity? But I'm going to come down to this point, and I'm going to get the same result. So whether it's positive or negative, I'm still going to be getting 0. So it is good to stop and think, does the same thing happen? In this case, it does. So let's think about, can we tell if it's approaching from above or below? So let's do the positive infinity. So we'll have 1 over x. X is approaching infinity, which is positive. So my numerator is going to 0, but it's going to 0 from the positive side. Well, the numerator is. In the denominator, I have a 1, which is positive. Well, maybe I won't put a plus there yet. I'll think about what's happening. 3 over x will be positive, so I'm going to do 1 plus something minus, and then minus something. So I'm going to do 1 plus something minus something. I can't tell. So which of these two is going to dominate? Is it going to be bigger than 1 or smaller than 1? Am I adding or subtracting? Can't tell, so we'll say, don't know. We won't use that information for this graph. With future information, we'll get more, but for this section, we'll say, I don't know if it's coming from above or below the asymptote. So let's move on to the vertical asymptote. And we want the limit as x approaches something. Well, I need to factor my denominator. So let's go with approaching 5 from the left. And then we'll do the limit as x approaches 5 from the right. Oh, negative 5. Good thing I left some space there. So denominator goes to 0, numerator doesn't, so I know it's infinite. I want to know if it's positive or negative infinity. So as I approach 5 from the left, negative 5, my numerator is going to negative 5. That's a negative number, always. The x minus 2, negative 5 minus 2, that'll always be negative. So I'm really just interested, how does it change around the x plus 5? From the left, slightly smaller than negative 5, plus 5 gives me negative. So the 3 negatives multiplied and divided give me a negative infinity. And here as I approach negative 5 from the right, it's like negative 4.9 plus 5 is positive. So here we'll approach positive infinity. I would like you to do the left and right hand limits as x approaches 2. I'll get your question in just a moment. So I hadn't started the recording, but here again, as I test, as x approaches 2 from the left, I'm approaching negative infinity, so my graph is coming down here. As I approach 2 from the right, my graph is approaching positive infinity, so it's going up there just on the right-hand side of that vertical asymptote where x is 2. Question? Well, even as we look back here, when we found the horizontal asymptote, what we're doing is we're saying, what does this function look like when x approaches infinity? It doesn't tell me anything about what the function looks like when it's not close to infinity. So in the middle of the graph, the asymptote doesn't tell me anything. The asymptote is saying as x approaches infinity or negative infinity, the extreme ends, it's going to look like a horizontal line. In the middle, it could cross it a billion times. That's fine. Yes, Nathaniel. On the left of x equaling -5? Well, I knew that as I approached -5 from the left, I was going down to negative infinity. So then I just assumed it was going to stay below. It's possible that this function actually comes up and goes like this, because there are functions that do that, but I don't have enough information to know. So I'm going to go with the simplest graph I can, given the information that I have. Oh, if I just leave this here, as we move on in this chapter, we're going to be getting more and more information from calculus to tell us what the graph looks like. And what we'll be doing is we'll be looking at points like, oh, are there any horizontal tangent lines? So if there's a horizontal tangent line, later sections will tell me where that is. It'll also say, oh, is there an inflection point where the graph switches from curving down to curving up? And that'll help me get a more precise graph as well. So all of that will come up in the next few lessons. For today, we're kind of limited with just draw the most basic graph we can given the information we have. All right, online, how are we doing? Thumbs up is good for those I can see. Some of you I can't see. Don't know if it's bandwidth or you're invisible or something. So, next question, check your understanding. So, take a little bit of time, work through that one, please, and we'll go over it in a few minutes. Can I get your attention, please? First of all, my intercepts, I just have one again at 0 and 0. That's nice, makes it easy. Then as I look at horizontal asymptotes, I get the same result as x approaches infinity as when it approaches negative infinity. So that's going to 0, that's going to 0, and I get y equals 1. Up to there, any questions? Nope, we're good. Looking at the vertical asymptotes. So there's my function with the factored denominator, so I'll have two vertical asymptotes again. And so as x approaches -2 from the left and the right, I get the infinities it's approaching, and then the +3 from the left and the right, and the infinities it's approaching. So as I approach -2 from the left, my graph goes up. From the right, my graph goes down. Approaching 3, it's going down on the left. So this one's going to be a different shape than our previous graph was, and up on the right side. So hopefully we ended up with a graph that kind of looks like this. Now, we can't tell for sure if the intercept here 0, 0 is a maximum. It's possible that our graph actually goes up and then comes down. We don't have enough information given what we did here with just limits and intercepts to tell, but that's good enough given the information that we have. Online, anybody have a question? The people I can see don't have questions. The people I can't see are silent. So we'll pretend they don't have questions. In class, we're good? Yes, Nathaniel. on the left side here that it was above 1. I actually couldn't tell when I looked at this function here if it was approaching from above or below. So I just said, well, since I know here as I approach -2 from the left, I'm going to positive infinity, I'll just go with the simplest graph, which has it coming down and approaching from above. Well, the thing is, here, if suppose x is approaching -infinity, I do 1 over negative something. So I'm subtracting a negative, which means I'm adding something. Here I'm doing 6 over a negative squared, which is positive. So here I'm subtracting. So I'm going to start with 1. I add a little bit. I subtract a little bit. I don't know if I'm greater or less than 1. There's just not, it's not clear enough. Okay. Give that. No. Last little bit of information. So this is just to tie into what we learned in Math 30-1. But we're putting kind of more rigorous or clear math notation to what was going on. So if as x approaches positive infinity, my function approaches positive infinity, that means I don't have a horizontal asymptote on the right side. It means my right end behavior is positive, so my graph is going up. So we already learned about end behavior for polynomials in particular. Similarly, as x approaches positive infinity, I'm looking at the right side of my graph. If my graph goes to negative infinity, it just means it's going down. So it's negative on the right side. And then similar as x approaches negative infinity. So just looking at end behaviors there. Not sure what the online people did if you talked about the quadrants it was in at the left and the right. But one of the options other than quadrants is to say, oh, right end is positive, which means y values are going up, or right end is negative, which means y values are going down. And that is the end of this lesson. I will stop the recording and